I will give you a very short overview of it from the point of view of the business, and then we will go into the details, into the internals. Okay. So log4j, I'm pretty sure that everybody knows, but from the business point of view, it's a very small component in the entire system. Okay, and this is if you can see the entire system, it's the one leg is a log4j. It's amazing that when this is under attack, the entire system is falling down. And this small library is very old. It's from 2003, and it's maintained by volunteers, you know, but very few volunteers. Even less than 10 people maintain it. It's amazing the effect of this small component. Okay, so let's talk about the business point of view of this problem. The bottom line, it's very, very bad security vulnerability. It affects almost everyone that use Java. For example, this is the top list: Minecraft, Facebook, Amazon, Apple, Google, LinkedIn, Tesla, Twitter. Even if you don't use it directly, but you use Tomcat or Spring, like us, for example, but many more that use these frameworks, they are also in this problem, in a big problem. So what is the threat? Again, from the business point of view, it allows to run code on the server. It's called remote code execution. And this is the reason that this vulnerability is also called log4shell. Okay, because the attacker can even open a shell on the server that run log4j. And from this shell, the attacker can get inside the network, even if the network is not reachable from the internet. It's only one server should be reachable from the internet, and using this vulnerability, the attacker go from that server into an entire large network. Okay, so security level is, for each security threat, there is a security level, threat level, and this vulnerability has a top number, which is 10. This is the top level, which means it is very easy to exploit. So the attacker don't need to be an expert. Even a child can use it. And the danger is critical. It allows remote code execution. It allows the attacker to run code on the server. And if the application on the server is run on, for example, with root permissions or whatever, with some strong permissions, then the attacker can do whatever he or she wants. This is the most severe vulnerability ever, I think, almost ever. And it was found, as far as I understand, on last December by after attacks on Minecraft and attacks on Alibaba. But I didn't find more details how this was found. And it's also called, from technical point of view, it's called, if you look for more details, it's called CVE 2021, and there is a number. Okay, and it exists, this vulnerability exists for the last 8 years. 8 years, since 2013. This means that in the last 8 years, hackers that know this issue can penetrate almost any server in the world. Okay? It's just as awful as it's I can say. Almost any server in the world was vulnerable in the last 8 years. And this problem was fixed in last December with version 2.16, okay, which closed the vulnerability. And each business that has log4j need to do it as soon as possible. And the business must also check if it was under attack in the last 8 years, attacks that weren't found. Since it was published in last December, there are millions of scans each day from hackers on all the servers in the internet looking for servers with all log4j, because it's so simple. So you can see it's every day there are millions of scans for such servers. By the way, one of the most common use of this vulnerability is to abuse the server to create bitcoins or some other coins like this. Okay, so this was a business point of view, and I hope you understand it's very, very bad. Now, let's go into the internal stuff, which is more interesting for us as developers. Well, it all starts in a new feature that was introduced in 2013, which is called lookups. And what it means, if we send a message to the log, at the beginning, the message was not a string, just a string that is sent to the logs. And there was an option to, and the lookups was added an option to insert data into the string, data that the log library itself inserted. So for example, in this error string, logger.error, there's a message looks up value and inserts, and then if we type stuff like this, $, bracket, and the name of an environment variable, then log4j itself will look for the value and put it in the message. Very useful. No need for us in our application to look for this information. We can just ask log4j to do it. Here's another example in the log4j configuration. It's also possible to use lookups. So this means that any log message that is sent to the application log file will have the following format: date, process, I don't remember what is this, time, and a value from the environment variable. Very useful. It's also possible to add a date lookup. Here it is. Again, great idea. An environment variable. You see, great. Even we can insert. We can look for Java information. You see, Java runtime. I can ask for log4j to put it, or Java's VM version, and the OS version, or whatever Java properties that I want to insert. I don't need to write in the application any code that gets this information. I just can ask log4j to put this stuff. Right. But then a new option was added to the lookup, which is called JNDI lookup. And this is the source of the evil. So JNDI is a Java feature, or Java API. It's short for Java Naming and Directory Interface. Very complex name. It just means that it's Java can provide an API, the JVM can provide an API for sharing configuration for multiple services. So just imagine that we have a system with several services or microservices, or maybe several servers, and they all need to know some stuff. For example, the URL of the email server. And they also, all of them need to know the name of the admin user or whatever, okay? So we can configure this information in each server, and each time we change the value, we need to change it on each server, and this is not really a good idea. The alternative is to put this information on some specific service that everybody knows its address, and each time a microservice or some server in the network need to know the information, it can just ask this service for the information. Okay, so this is JNDI. It's an API to ask for information, which is usually a configuration stuff. And who implements this API? We know that LDAP servers implement this API. LDAP is a server that holds information about people. And there is a DNS server, which holds information about name of a machine or name of a site and its IP address, this mapping. And there are also servers that implement RMI, which is remote method invocation. It's a technical stuff of Java to run code remotely. And here is it's not open. Okay, here is an example for LDAP. Okay, this is our server. It can create a JNDI request to the LDAP server, for example. And the request say, who is John? And the reply will be information about John. This is the name of John, this is a company, this is whatever, I don't know. So very simple way. And what happened is that log4j added an option to ask information using a GNDI. So let's say we can put a message call, command say logger.error, some text, and then we write $ and JNDI, LDAP, and this is the information that LDAP needs. And what log4j will do, before it writes this line to the log, it will send a JNDI request to this LDAP server, ask for the information, get it, and insert it into the string. Okay, so it's a great idea in general because we can add to log messages in any configuration stuff that we want. We don't need to run the JNDI ourselves in the application. So it sounds a good idea. Okay, so let's see an example. Let's say that we have a search engine, so a site that runs a search, and this site has an input. Okay, input box. And the site just keep a log of each search, like this. Search page, searched issue 4, and the string that was searched. But what will happen if the user will type this command, this string in the input box? Okay, you can imagine this string will be put here. Okay, let's go back to the string. What the server that runs the search page will do, it will ask log4j to print, to store the search term in the log file. Log4j will see this string and will run a JNDI lookup to this server. Okay? log4j will not check that this server is a valid server. It trusts us, the developers, that this server is okay. But what will happen? Log4j will go to the attacker server, get the response, and will add it to the log. Okay? So what? So what? This sounds not really a problem. Okay, but the problem is, before I go to the next slide, the problem is that JNDI API, okay, this API is working using Java serialization mechanism, okay? So before I continue, I just want to explain you very short about Java serialization, or marshalling, which is another name. Java serialization is a way to take an object from the memory, convert it to some string or to some packet, okay, to some packet data, move it to the network, and on the other side, Java will convert it again to the object. Okay, so we have an object, Java serialization, pass it as a packet, and the object is created on the other side. Okay, so if there is a request, the request is sent to here. This is expected to build an object. The object is serialized, and here the object is created again or deserialized. Okay? What it means that the job is created? It means that some method, maybe it's a constructor, maybe it's init method in the object is called in order to create the object. Okay? Let's say that the object that is passed is this object. See, it's a class of the attacker. It implements object factory, and object factory, in order to create an object from the object factory, and this is, by the way, what log4j expects to get an object from object factory, it will call the get object instance method to create the object. Okay, so it calls to the LDAP server get the serialization of the object, and then it calls this method to create the object. This is what is expected to be done. Okay, but what it does, the attacker put logic inside to run command. So it means that attacker can send objects to the attacked servers that run any command that it wants. It can even spawn a thread that run a shell that run a loop to get more and more commands and execute them with the permissions of the server on the server machine itself. Okay, amazing, just amazing. This way, the attacker can get access to the server. And now any child can do it because there are tools to create such objects. And all we need to do, all the child need to do, the attacker need to do, is to cause the server to put something, to put the input on the log. So you say how the attacker can cause the attacked server to write the string to the log. How? Well, there are several ways. For example, let's say that we put it on the username in the login screen. Usually servers, especially production servers, have a log of suspected logins. For each login that fails, it will write to the log, the user and the name of the user tried to log in and failed. Voila, very simple. Another way, to put in the header in the user agent header of the HTTP request. And send whatever request that we want to the server. It will fail. It does not contain the cookie, it does not contain whatever is needed, and most servers on production will just write to the log. We got a suspected packet, and we'll write the information on the packet, especially the header, the user agent header. Voila. We are in the server. It's so simple. That's all. That was a very short introduction to log4j, log4shell. Any question?
Yes, so would users of the first version of log4j be exposed to this vulnerability?
Users of what?
Version 1.
No, it was introduced on log4j 2. By the way, there is some people that say that this vulnerability was not introduced by mistake. They say that maybe some government added the malicious code to log4j because it's an open source and nobody noticed. But there is no evidence that what was happened, by the way.
Did they solve it by removing the functionality in the new version? You know?
They turned it off by default because this feature was turned on by default. The JNDI lookup was turned on by default. And all they did is to turn off by default. That's all. And it doesn't work. So it doesn't matter if you put the string, it will not do the magic.
But they released several different versions of the.
Yes, there are more. After this vulnerability was found and fixed, they found another more complex vulnerability that is similar, but it's not so simple as what I described. So they released another version, but it's not really needed to, at least for us, not really needed to upgrade to the latest version.
So what action Control Tower did when the incident happened?
Well, what we could do at the moment it was found is to add a flag. It was supported by the log4j versions that we had, a flag that say that this feature, the JNDI lookup, is disabled. Once we added this flag to all our containers, we solved the problem. And then after a few days, or maybe 1 or 2 days, we also upgraded the log4j library itself. Actually,